Hello sir, our topic is using logistic regression to predict the probability of a customer making a purchase, say in the next 3 days, based on his past purchase data. So basically my teammate is Bimal Horo and I am Vijay Pampana. Moving forward, so the objective of our project is to predict the probability, as I said earlier, of a customer making a purchase in a grocery store within the next 3 days. And this we did by using logistic regression on the previous data of his purchases that is available. So the source of our data is basically kaggle.com, which is a competition website where it conducts open challenges for people who wants to do number crunching. So we took this data from Dunhamby's challenge. Basically the data is contains customer ID, visit date and visit spent. So customer ID is basically a unique ID that every customer is assigned, and visit date, this variable gives the date of the purchase of the customer, and visit spend, of course, as it is evident, amount spent by the customer in the visit.
So this one is the transaction level data, which means that a particular customer is having multiple records. So
So the data preparation, in the data preparation part, what we actually did was, the amount of data we had was huge. It was in lakhs. So we picked out randomly 1,000 customers and records of all the transactions made by them during the period 1st April to 19 June. And so we divided the data to 1st April to 16 June, which will be used as the framework for our independent variables. And the data from 17th to 19th June will be used as the base for our response variable. So if you can see the breakup of the data, the total data available is till 19th of June, but we started from 1st April to 16th of June. We used the data for predicting our independent variables, which we'll tell you in a minute. And the transaction data is used for defining the responsible, from 17 to 19 June is used for defining the response variable. So coming to the response variables and the independent variables, basically as clearly evident from the slide, it's like we formed 8 independent variables out of the original data available and 1 response variable. The response variable basically is if the customer transacts between 17 to 19 June, then the value of the variable is 1, else it is 0. For independent variables, the 8 independent variables we found are total spend, which is the total amount of money spent by the customer during the period from 1st April to 16 June, and average spend is the average money spent by the customer per visit during this period, which is basically the total spend by the number of visits by that particular customer. Then max spend, that is the maximum money spent by a customer during any visit of his between 1st April to 16 June. The last spend, the amount of money spent by the customer in his or her last visit. And the frequency, that is the total number of times the customer has visited the grocery store. The day's first visit, that is the number of days between the first visit to the store and the day of prediction, that is 16 June. And the day's last visit, the difference in days between the customer last visited the store and 16 June. So, and we thought these might have some effects. That's the reason we considered days first visit and days between last visit and the prediction date also as independent variables. So visit interval, the average number of days between 2 purchases. These are essentially the basic 8 independent variables of us. So the data set, as you can see, it has customer ID, the total spend, the average spend, then the max speed, the last spend, the frequency, days first visit, the difference between the days first visited and 16th of June, the prediction date, and days last visit, the last visited date and 16th of June, visiting interval, and the response variable, which is either 1 or 0 based on whether he made a purchase or not. This is the sample of the data that we had extracted.
And in this data set, as we can see, each customer has just one record. So this is actually a summarization of the transaction data which we had.
So basically we have data for customers, and say a customer X might have visited a store n number of times, and he might have made say n number of purchases or some p number of purchases. But all those transactions, what we did was we summed up to get this total spend, and we divided it by the number of times to get the average spend, and max spend all are explained earlier. So the model, basically what we did was we took 732 of the responses out of the 1000 or 997 to be precise that we extracted. We took 732 for modeling and 265 for validating the data. So we had run the logistic regression for the response variable based on the 8 independent variables as we discussed earlier. So if we see this test, in this, the test that all slopes are 0, it said p-value is close to 0. So this essentially tells us that there is at least one or more independent variables which is explaining the response variable as such. But when you get to the data and see, if you see the p-value for frequency, which is 0.026, and p-value for visiting interval, which is 0.037, so these two have less than 0.05 p-values, and we assumed and hence we thought that these might be the important factors which are affecting or determining the purchase, whether it has taken place or not. And also if you see, day's first visit has got the highest p-value. With this we are going to use in later part of our analysis. We'll explain that in a minute. So in measures of association table, we see that concordant, so 75% of the data is concordant, which means that 75% of data is in line with this model, with this analysis. So the step 2 involved carrying the logistic regression number of times, eliminating one independent variable at a time. So in the first stage, when we carried out with all 8 independent variables, we found that day's first visit had 0.785, which is the highest. So we eliminated that, and we carried out logistic regression for the other 7 variables, and in that we found day's last visit has the highest p-value, and only 2 values, the frequency and visiting interval, have below 0.05. Similarly, then we eliminated day's last visit and ran it for 6 independent variables and one response variable. Similarly, we started eliminating until we came up to we arrived at total spend, frequency and visiting interval. That is 3 variables which are all the independent variables used in the logistic regression, having a value of less than 0.05. And again, the test that all slopes are 0, which essentially talks about again whether these independent variables explain the dependent variable or not, is 0.000, that is near to 0 again. So this again supports the argument that one or more of the independent variables explain the response variable. Again, the concordance was found to be 75% and discordant was about 25%. So this was the model basically. So the model that is based on our analysis of the 732 customer records is log of odds is equivalent to this minus 0.324495 plus 0.0001097 into total spend. So you can find the equation here, and these are the other things. So this gives us the probability of a customer purchasing in the next 3 days, this model. So we use this score for validation dataset and for using the above equation. So what we did was we arranged the entire dataset of those 265 individuals in the descending order of the probability. So essentially we get probability of each individual making a purchase based on this data. Then we arrange the data in the descending order. So the customers were arranged in the descending order of their probability of making a purchase based on this data. Then we split the entire data set into 10 equal parts or deciles. So the top 26 the top 26, that is the top 26 having the highest probability, form the first decile. Then the second decile has the next 26, the third decile has next 27, and so on. So what we found out was, among the top 26, that's the first decile, only one was an outlier, while our model correctly predicted for 25. So the percentage purchase that correctly predicted was 96%. And similarly, when we go down, it's for the second decile, our model correctly predicted for 22 out of 26, that's 85%. And for third decile, that is the third set of individuals having the highest probability, the third highest probability of making a purchase, they have about 20 of them were predicted correctly out of 27. So on the whole, if we see, our model was quite robust in the way that if you see here, if you notice clearly, this is whether they have made a purchase or not, which is a factual data. Whether they have purchased or not, again no purchase, which is again a factual data. So our probability is higher in the top 5 deciles, that is, and again it is lower in the bottom half. So we expect our model or the greater number of actual purchases to fall in the top half of our deciles. So if we counter check that, when we counter checked it, it actually turned out to be true, and it turned out that 63% of total purchases fell in our top half, that is in the first 5 deciles. So again, the cumulative percentage of population is 50%. So basically our model is again supported, is doing pretty well, which is again supported by this fact that 63% total purchase falls in the top half. But and another counterintuitive thing is the percentage purchase, which is expected to go down, linearly decrease as we move down. But there is an outlier, 69%. This might be due to some noise in the analysis, and so might even decrease the robustness of our model as such. So when we get to the ROC curve, so in ROC curve what we expect is, if we go back one slide again, so out of 265 people whom we used for validation, 58% of them actually made a purchase. So ROC curve is expected to be linear, with out of every 10% of people, 6%, about 6%, that is 58 is approximated to be 60, 6% is expected to make a purchase. So out of 20% it's 12, and it should go on. But our model says, instead of picking randomly 10%, if you pick the 10% from the first decile, you will get a higher chance of having the population who made a purchase. So if you go back, it's about 16% here. So it's again justified here. So 16% of the total purchase is here. Similarly, so the ROC curve is basically a bit curvy. Generally we say the greater the curviness of the ROC curve, the robust the analysis is. So our analysis is quite robust, again evident by this. The other explanations can be found out in detail in our presentation as such. So conclusion, Bimal will carry on.
So here, so concluding our model, the model equation, the coefficients which we get, that are pretty intuitive. As we can see from our previous slide, here as the total spend is increasing, the probability of purchase also increases, which is which is pretty logical. Also, if the frequency is of the customer visit is increasing, the probability of purchase is also increasing. However, if the interval between the visits is decreasing, that is, if the customer is having, if there are a lot of days between two purchases for a particular customer, then the probability of purchase decreases. The model equation applied on the validation sample also shows pretty good results, except for one place which we have marked over here, which is a little inconsistent. However, I mean, that can be improved if we do a more detailed univariate analysis, and if we do bucketing of variables and do the linearity tests and all that, that should improve the predictability of the model. However, that is difficult in Excel because of its limited functionalities. That can be better done in softwares like SAS. Demographic information of the customers, that would help in better prediction of the customer behavior. Also, the further extension of this model could be that the monetary value which the customer would spend in his next purchase, his or her next purchase, that can be predicted, and be a linear regression model could be used for that. So that will enhance the model. Also, if there is product level purchase information in this data, that would also be very useful for the store manager, because then he would be able to plan out his inventory in a better manner. So that is what our conclusion is from this.
That is it. Thank you, sir. Thanks a lot.
Thank you, sir.